Okay, let's try that again. Good afternoon. Okay, so this year I decided to continue on my last year's trend. So I took the things that annoy me very much in support tickets from the customers, and I tried to put it in the presentation to reduce the number of such tickets. So basically this year we will talk about, again, underused MikroTik hardware and software features. An alternative name for this presentation could be the path between fastpath and advanced features, because I don't know why, but most clients think that you can go either fastpath or use advanced features. You can't do both things at the same time. So I will try to break that preconception so that you can use both in your configurations. So objectives of the presentation. So to help you combine slow pass and fast pass features, allow you to properly use our equipment so that it can do more. Of course, encourage you not only to update RouterOS version, but also change your existing configurations to more optimal ones, and of course to reduce the number of support tickets to the support@mikrotik.com. So presentation plan is very simple. So I tried to combine all the problems into examples. So we will talk about the proper hardware choices, proper hardware usage, proper layer 2 feature usage, and then we'll go to our favorite layer 3 feature usage. So let's start with the hardware choice. So this is by far the most popular problem sent to support. So I have this router board 411. I have just 700 firewall rules. It doesn't work properly. So just 700 firewall rules. Okay, so, and examples like that we see daily, where we need to address and select, allow customer to choose the proper hardware. I understand that there's many MikroTik hardware choices, but the first thing that you need to do is to choose properly. So to combine these all examples in some logical way, I would need some help. So the first person that will help me will be Dave. So Dave is a typical network administrator. He is certified in all other most popular big brands. As you can see some brands on his t-shirt. And the disaster happened in his server room. I don't know what disaster, but basically he needs to fix it now because his boss told him that we need to go back to the operation, and the only spare hardware, as it occasionally happens, is some small box from someone called MikroTik. It says 750 that some friend gave him to try some years ago, and so on. So he gets a quick search. He needs MPLS, needs L2TP IP security, firewall routing. He sees that that box can do that. He gives it a try. So a few days later, Dave already changed his t-shirt. So he's in shock and very impressed how $60 box can do all those things that he needed then and right now. So he becomes a MikroTik fanboy, and unfortunately that means he starts sending support emails. A lot of them. So because Dave starts to getting a few problems. So the first problem, so on daily database exchange, throughput is limited to 1 gigabit per second total. So not full duplex, but total. He can get only 500 each way. And as soon as he sends another way a little bit more, the first way drops down. And the CPU is hitting 100%. He used routing with large packets. So how to diagnose this problem? Dave needs to use this block diagram of 750G R3. And he will see that he uses Ethernet 2 and Ethernet 4 in this communication. And if you take a look at diagram which is available on our hardware page for every product, he will see that ports 2 and 4 are connected to the same 1 gigabit line to the CPU. So 2 and 4 connected to the same 1 gigabit line. So that means that these two ports share 1 gigabit full duplex speed. So to solve the problem, Dave needs to switch one of the ports to this 1, 3, or 5 port, and he will get a full gigabit. Okay, Dave reads further. He discovers there's such thing as switch in a MikroTik. So he switches 2 ports, and again, the speed is down like a previous time to 1 gigabit full duplex for both ports. So, and then there is another diagram of 750G R3. So as soon as you put at least some ports in the switch will get a dedicated line of 1 gigabit per second, and all other ports will use another line of 1 gigabit per second. So I myself think that these are very important things to know when you use your hardware. This 750 is one of the extreme examples because it changes behavior depending on your configuration of your switches. Other products don't do that, but please, every time when you look, take a look at the block diagram of the product to see how it will behave and what speeds can you get. So basically, we found out that there's such bottlenecks. So to avoid, in his example, he needs to switch to the software bridge instead. Then the dedicated lines will remain as in the first example. Okay, time flies by. Of course, the fix worked for a while. Now he needs to improve on the fix. And he is looking for the new hardware to replace his 750G. So, and he sees that 3011 could be a very good choice. So he needs more switching throughput. He now examines 3011 diagram from his previous examples. So looking for bottlenecks. And of course, he's getting more and more enthusiastic about MikroTik and sends even more support tickets. So if we take a look at this block diagram, you can see that 3011 has 2 separate 1 gigabit lines to each of the 5 gigabit ports. And in case you use SFP port, the second switch loses one of the lines to the SFP port. So also a very important thing to notice about this change over here. So, but of course, as soon as he switches the hardware, he runs into next problem. His L2TP plus IPsec connections are overloading the router. CPU is at 100%. Throughput is down compared to 750G R3. And, but diagram suggests that 3011 should be more powerful. So what's wrong? So then you need to go to the same hardware page, and we have performance tables over there. So, and the reason why he sees this CPU increase is because 3011 doesn't have IP security accelerator unit, but 750 does, which also indicated in the diagram. And also, if you take a look at the performance, then you can see that when we take small packets, 750 can do 1 million, and 3011 can do 1.5. But if we take an IP security performance table, you will find one for 750, but there's none for 3011. So that's a dead giveaway that there's no hardware acceleration for IP security on that hardware. So this is second most common problem that we get, using improper hardware for improper jobs. So if you want to use something for IP security, encryption, and such things, get a unit with the accelerator. Okay, so Dave digs deeper. So he examines now hardware, IPsec hardware encryption performance numbers, and decides that he will replace 715G R3 for old version of 1100's AX2. So he also examines block diagrams, he sees some switches, he sees some free ports, and decides to use Ethernet port 11, 12, and 13 for the main traffic of his network. So if you take a look at the encryption numbers, you can see that 1100 is 3 times, no, this is throughput numbers. So 1100 is more than 3 times faster on average in the whole table than 750. And if we take IPsec acceleration, so numbers are 2 times, 2.5 times more IPsec encrypted throughput on old version of 1100s. But again, they've run into the problem. So 1100 doesn't perform as expected. Performance is not better, but even worse. Basically, especially on these 12 and 13 ports. So again, to diagnose this, you need to take a look at the block diagram of that board. And the reason of the problem is Dave is using management and emergency bypass port for the main traffic. So what's the difference between these 2 ports? It's very simple. If you can see that switches have direct connection to the CPU and port 11 have direct connection to the CPU, emergency bypass port and management port have to go through the PCI Express line, and it's much more slower and much more expensive to work with. So these 2 ports on the old 1100 shouldn't be used for your main traffic. As you can see, there's a bypass group. That means that if device shut down, all traffic will be straight going from this port to this port. So hardware bypass feature on 1100 series. So the solution is to make sure that the traffic goes in these 3 general directions, which is much more easier to proceed in the CPU. It will generate the less load and give you best performance of the hardware, just by switching to the right port. So we get finally to the place where Dave buys the right hardware. So he goes for 1100 new version AH X4. And of course he starts to investigate new possibilities to use MikroTik, replace his own other solutions, other places, and so on. And of course, this results in even more mails from Dave to the support. So around this time, we always make a special folder for Dave to make sure that he gets answered at least sometimes. But yeah, that's the situation. That's one of the typical situations at support that we get. So if we take a look at the block diagram of 1100 X4, you will see that there's 3 groups, each of the group connected by 2.5 gigabit line to the CPU. There's no PCI ports, so all ports are equal. So you can see which ones go to the switch, which can be switched together, which can be routed, and so on. So, yeah, if we take a look at the hardware, X4 is even faster than X2, 2 times faster than X2. And if we go to IP security acceleration, so it's even more than 2 times faster in IP security acceleration. So this part of the presentation, I will repeat again, is please make sure that you buy correct hardware, because most of the problems that you see is usually trying to use something that was not designed for that usage for the wrong purpose. And by simply switching ports or changing some wires, you can improve your performance of MikroTik hardware very quickly and very fast, and sometimes surprisingly. Yeah, just make sure all the data is available to you. Just log into MikroTik page. Each product should have all these data up in a week or 2 after we release the product officially. Yeah, sometimes we are in the MOM, for example. We cannot put those numbers, but they are for all products. They are there, updated, and so on. Okay, let's go to the second part of the presentation. So, meet Mike. He's a self-made businessman. He has a small office that works with the customers at premises. He has several employees. He has few servers. He's a strong believer in all-in-one solutions. So, and he's looking for one network device that will satisfy all his needs. So at this point, he needs like 5-port device to connect to the internet, connect few PCs, and connect few servers. Also, guest Wi-Fi, custom and local Wi-Fi for himself. So Mike's friend Dave, from the previous part of presentation, suggests him to use the new Hub AC Square. So, of course, Dave explains everything about a block diagram, that this is one of the best devices he can see in the block diagram. It even have a 2 gigabit connection to the CPU. So 5 ports share 2 gigs, not 1 like in previous models. So, and it has a separate 2 wireless, 5 and 2 gigs. So Mike starts to configure this device. So he starts up with version 6.40.5. He has internet ports. He bridges all the other ports, including wireless, some virtual wireless access points for his guests, and other Ethernets. And now he needs to isolate his servers from his guest network, where the customers connect. So, of course, he goes to the interface bridge filter and restricts, makes a firewall on that device. So idea is not so bad, but implementation is just wrong. So the problem is very simple. When he does this configuration, server to workstation Ethernet speeds is not reaching 1 gigabit per second. CPU is very high. Internet communications are low. If he takes a look at tool profile, he sees lots of bridging load. So the reason is very simple. With this configuration, all the traffic is going through the bridge in, I call it slow pass, so regular pass, which goes through all the features. And all the traffic also goes through the bridge filter. So what can he do to fix this? First of all, of course, our new bridge implementation, which is the freshest thing from actually version 7, backported to version 6. So congratulations, you are using 40% of version 7 already. So, and this version have this hardware offload functionality. So basically, if you have a switch chip on your device, you can use some features in the switch chip and work with the traffic in the switch chip, not sending it to the CPU and not spending CPU cycles. So each port have this HV hardware flag that you can enable manually. So for new bridges, it's enabled. And if ports are in the same switch, they will automatically use the hardware switching instead of bridging. So the traffic will go through the switch, not through the CPU. So basically, what I'm trying to say, you have this ability to send some traffic to the hardware the fast way, the fastest way that's there, so even faster than fastpath, through the hardware, I would say hardware accelerated way. So, and you can control it. So why not use it as additional filter before this bridge filter? Why not send all the traffic that you want to go the fast way through the switch chip and leave only the traffic that you need to filter for the actual filter? So basically, just enable hardware flag for the ports that you know that are secure, that are connected to your servers, to your computers, and accept everything, enable this hardware yes option on those ports, and that traffic will not ever get to the bridge firewall. So, and then in bridge firewall, you can filter out those virtual access point guests that's coming in so that they don't get somewhere except the internet, for example. So this is one way how to combine the fast way and the functionality you might need. So days go by, requirements grow. So internal devices work perfectly to the servers, load is normal. But Mike notices that some of the customers, when they arrive to his business, are abusing internet with the heavy downloads. So Mike wants to put some queues on. So what Mike does, he looks in the internet. The first thing that he sees that he needs to enable use IP firewall yes in the bridge settings. And use simple queues for his guest IP access point. So the problem that comes out, first of all, queues doesn't seem to work on all traffic. Some traffic queue sees, some traffic queue doesn't see. So if we take a look at the tool profiler and the packet flow diagram and some firewall logs, you will be able to debug that bridged traffic now travels through IP firewall, including connection tracking, which is very expensive from the CPU. But from routing perspective, guest traffic still comes from the bridge interface, not from bridge port interface. So you cannot create a simple queue that captures both routing and bridging traffic at the same time if you use interface as a target. So what can be possible solution? Not many have noticed that there is one place for queuing which happens after routing and after bridging when they both traffics comes together. It's the interface HTB over here. So routing goes that way, bridging goes this way, but both traffic meets over here. So you can use bridge filters and mangle. Both of these options have packet mark. So you can mark packets there with the same mark, and then use this packet mark in Q3 and place that Q3 on that interface. So then it will be placed on that interface HTB. As soon as you create that Q3, it will automatically replace your existing queue interface queue with that Q3. And basically, you don't need to use IP firewall anymore. This means that you can still use the fast way for your bridging traffic without any issues or problems. So by this example, I try to emphasize that first thing that you try on internet, which maybe it's easiest to configure, is not always the fastest way for process the packets. Because just using packet marks where it's supposed to use, so for bridged traffic in bridge filters, for routed traffic in routing filters, It's much more faster and better than just sending all bridge traffic to the IP firewall. Okay, so life goes on. Now we get to the business-specific issues. So guests are now limited to certain speed. And now Mike looks into exactly what his customers are using his network for. So he jumps into the network DNS cache and sees that customers are browsing competitor web pages to compare prices. Maybe they don't need his services here. They can go somewhere else. And also he sees that lots of customers are using YouTube and Facebook. Lots of employees are using YouTube and Facebook during the work time. So he decides that he wants to block off this traffic. And of course, first things that he goes for layer 7 and makes configuration something like this, which is completely and utterly wrong. So never do that like it's written here. It will just kill any performance of any router if you do a layer 7 like this. So why? So you will see high CPU load, increased latency, packet loss, jitter. YouTube and Facebook will not be actually dropped. And in tool profile, you will see high layer 7 rule. And this is because each connection is rechecked again, and again. And layer 7 is basically checked at the wrong place and against the old traffic. So what is layer 7? Layer 7 is method for searching special patterns. That pattern is usually 10 packets or 2 kilobytes long. So you cannot use drop with that. If you drop the first packet, you will never get those 10 packets or 2 kilobytes to actually try to match that pattern. You need to collect that data first. So direct actions as accept, drops, and so on with layer 7 is not worth. The only thing that you can properly do with layer 7 is mark connection when it actually matches the pattern. So that's the basically only thing that you're supposed to do with layer 7, in my point of view. And the whole patterns, every pattern in the internet is for these 2 kilobytes or 10 packets. You cannot find some pattern which works only with 1 or 2 packets. So usually when somebody writes a layer 7 pattern, it's for this set of packets or this amount of connection. So the proper way to use layer 7, and this is the old way, is to use this connection mark. So basically when you meet your pattern and this connection is not marked before, so nobody has recognized this connection as anything else, you mark the connection for this particular site, in my case YouTube. And when you've done that, you can do whatever you like with those packets. So for example, mark them and then drop them in the filter. But as always, everything is improving. There's a new feature, Tls Host. So basically, now the most internet use is HTTPS sites, which is much more harder to catch. So in 6.41, we introduced this firewall option that allows you to block these sites based on this TLC traffic. So it just uses a glob-style pattern to match. So basically, it's very simple, very specific version, and much more faster version of layer 7, only for this TLC type traffic. So in the implementation, the new one looks very simple. So you just take a TCP traffic for ports 443, and you put a pattern. So try to reject all the Facebook and YouTube pages, and this one works. Of course, the life goes on. Mike is happy, everything is working, sites are blocked, but he starts to dig into the features. How can he get more from his features? And he discovers fast track. And as we all know, fast track, basically it's a firewall rule where you can send some traffic the fast way through the routers by skipping all the other features except connection tracking. So it works only for TCP and UDP for IP version 4. And basically, as soon as you send it to this fast pathway, that traffic becomes invisible to the firewall, queues, and some other facilities. So basically, he sees in the internet the first implementation of fast track connection. So you take connection state, establish it, and relate it in forward chain. You just fast track connection it, and then accept those traffic because some of the packets usually goes through the slow pathway to refresh the connection tracking timeouts. And this is the most common and almost the only rule that I have seen in the support tickets that users use fast track 4. But guys, this is firewall. There's like 60, 70 options that you can use together with this. So, of course, as soon as he enables this fast track connection rule, Mike starts getting problems. So the first problem is layer 7 and Tls host options stopped capturing traffic. They don't block YouTube and Facebook anymore. Counters of the rule doesn't count, but the fast track connection rule counts pretty nicely. So the reason is very simple. If that rule was added, layer 7 and TLS hosts doesn't get the required packets, so it doesn't get those 10 packets or 2 kilobytes or whatever they need to recognize this connection. For example, TLS host gets this number only on 3rd packet of the connection. So, and if you fast pass starting from 2nd packet, then it will stop to work. So there's a very simple solution. You can do a faster connection for the connections, all the bytes for connection starting from 10 kilobytes. So the first 10 kilobytes will go the slow pathway, will be matched by layer 7, will work in TLS host, and maybe even some other facilities that you need. And then, if it's still there, it can be fast-passed and get out of the way. So you can combine layer 7, TLS host, with the fast-track connection. It's not black and white. You can use both features, the fast and the most complicated at the same time. So, again, so Mike's business is growing, so he decides that he wants to open a few more stores, and of course he needs to interconnect these places with VPNs securely. Devices should be in the same subnet, so layer 2 subnet, and they should have high throughput. So he reads something about IP security. He, of course, have my favorite option in a firewall, Masquerade, on the both ends of the tunnel. And of course, Mike have a problem. IP security packets get rejected, tunnel cannot be established, and if he sniffs this traffic, he sees that NAT rules, that Masquerade rules, are changing his source address for encrypted packets. And this source address doesn't correspond to IP security policy. So what can he do? He can use the feature that one previous presentation already covered. He can use the firewall RAV table, which happens before the connection tracking. And you can choose what traffic to send to connection tracking and what traffic not to send to connection tracking. So if you're not sending something to connection tracking, there will be no defragmentation. NAT will be skipped, which will help in this particular case. And of course, some of the other features will not work. And this traffic will have connection state, the new connection state for these versions, connection state untracked. So the solution is just have two simple row rules that accept this traffic in a row before we send it to the IP security for encryption or decryption. We actually played with the idea to add these rules automatically, and I'm not sure if they are already in automatically in RC version or not. I need to double check that. So, of course, we're talking that we need layer 2 connectivity. When we work with layer 2 connectivity, by far the most popular example still how to securely bridge to local networks is to run L2TP and run Ethernet over IP over it. But it's a double tunnel, so tunnel inside the tunnel, so web pages slow down. And also the strange suspicion that it's not secure enough, and some competitors know your secrets. So you can all diagnose that with bandwidth test tool, with a ping tool, and some different packet sizes. And basically, the bottom line is PPTP and L2TP is not secure anymore. So use it just a good old plain way. We don't suggest to do that anymore. And another thing is there's lots of fragmentation because of this double header of Ethernet over IP and L2TP tunnel. So the packet is quite small and need to be fragmented. So the correct implementation is very simple. You just create Ethernet over IP tunnel, and you just specify IP secret option inside that tunnel, and this tunnel will instantly be running the highest security available so far, so IP security, IPsec encryption automatically, and you don't need to do any configuration. You just need to specify on the both ends same passphrase, and that's it. Your Ethernet over IP tunnel is completely saved. And of course, we go back through the numbers of IPsec throughput that we have these tables over here. So as you notice, most of our devices lately come with the IP security acceleration unit. And this is the reason why all the software features also tunes into the IP security. So basically, we're making hardware for you so that you can use the most secure way, the fastest way possible. So always please double check if the hardware, what is the hardware performance with IP security. And if you use any tunnels for the security, the only thing that I can suggest you right now from the stage is to use IP security. Any other means are getting less and less secure day by day. So that's the only way how to VPN our days, if it has, at least in some parts, IP security. Okay, I hope I opened up your eyes for few new things to think about. Okay, that's it for me. Thank you.